Okay, do you guys remember when we did arithmetic sequences? It was a pattern where, you were adding a certain number every time. And you were never subtracting. Sometimes you were adding a -5, but you were still always adding a number. Well, this time, we're going to do geometric sequences. And that's going to be where you multiply each time. And we're going to call that R. So the common ratio, that's what you're multiplying by each time. That's supposed to be an apostrophe. So what we're going to do is first decide whether a sequence is arithmetic, geometric, or neither. I feel like the addition ones are easier to see, so that's where I always start. What you're going to do is take the second number minus the first number. If it's arithmetic, it has a common difference. If it's geometric, it has a common ratio. And if it doesn't have either one of those, then that's where it's neither. So to find the difference, take the second number minus the first number. 3 minus 1 is 2. 9. Then do it, just like keep repeating that process. 9 minus 3 is 6. Okay, I'm already can tell that these are not arithmetic because the numbers aren't the same. So what I'll try now is dividing. Take 3 divided by 1 and you get 3. 9 divided by 3 and you get 3. 27 divided by 9 and you get 3. So this one is geometric. Oops, here we go. So try it again. Negative 15 minus negative 20 is 5. 5. 5. Since you're adding the same amount each time, this one is going to be arithmetic. And here's the key. If it's arithmetic, it's not geometric, okay? It's one or the either or neither. So here, 8 minus 2 is 6. 6. Whoops, 8. So it's not arithmetic. Let's try for geometric. 4, and that is a fraction. I don't even know what it is, but I know that it's a fraction, and fraction is not the same as 4, so it's not geometric, which means that this one is neither arithmetic or geometric. So to find the next 3 terms, what I'm going to do is, first of all, figure out what is the common ratio by taking the second number divided by the first number. And 15 divided by negative 3 is negative 5. And then I'm just going to take, that means R equals negative 5. That means I'm going to take this last number and multiply it by that common ratio, however many times it says, in this case 3 times to find that. So 375 times negative 5 is negative 1,875 times negative 5 is 9,375 times negative 5 is negative 46,875. Now, do you remember with arithmetic sequences, I said you never ever subtract, you always add? Same thing here. You never divide, you always multiply. Because it's easy to say, oh, well, you're dividing by 3 each time. I need you to turn that into multiplying. So dividing by 3 is the same thing as multiplying by 1/3. So your common ratio is actually 1/3, not dividing by 3. So now I'm going to take 1/3, and I'm going to multiply that by 1/3, which will give me 1/9. Times 1/3 will give me 1/27. Times 1/3 will give me 1/81. So let's write an equation. You're going to love this because it's so easy. There's literally no math except for finding the common ratio. Here's the formula you're going to use. Again, A1, just like last time with arithmetic sequences, A1 is the first term and R is the ratio. So here's what you're going to do. A sub n equals A1. The first term is 96. And then R is the common ratio. So take 48 divided by 96. I mean, really, you could do it to any of them. I can actually see it easier in my head to do 12 divided by 24, and I know that that's 1/2. And then n minus 1. Ladies and gentlemen, you can't simplify anything. That is the equation. The equation is done. Once you find common ratio, plug it in, done. Now here it does say to find the 10th term. So that means I'm going to be plugging in 10 for n, so that I have 96 times 1/2 to the 10 minus 1 is 9. And 1/2 to the 9th power is going to be 4.5 times 96 is 432. That's your answer.